It's important to understand that in many situations, the outcomes are not equally likely. So a coin or a die may be unfair or biased. Two math professors in Europe had their statistics students test the Belgian €1 coin and discovered that in 250 trials, a head was obtained 56% of the time and a tail was 44% of the time. So it seemed to show that this coin is not a fair coin. However, it would be more helpful to do more repetitions to get a more accurate conclusion. Some dice may be biased as well. So look at the dice in a game you have at home. The spots on each face are usually small holes carved out and then painted to make the spots visible. Your dice may or may not be biased, but it's possible that the outcomes may be affected by the slight weight differences due to the different number of holes in the faces. So gambling casinos make a lot of money depending on outcomes from rolling dice. So casino dice are made differently to eliminate the bias. Casino dice have flat faces. They don't have holes in them, so that each side has a chance of being equally likely to occur. So later we'll learn techniques to use to work with probabilities of events that aren't equally likely. Here are some more examples. The probability that a particular knee surgery is successful is 0.85. It says find the probability that 2 knee surgeries are successful. So in this example, the sample space is S, so that's the total number of outcomes, which would be successful, successful. The first one is successful, second a failure. First one a failure, second a success, and then both failures. So, but the probabilities of the events are not the same. So the answer to the question is not 1 out of 4. In order to calculate this, we have to look at additional probability rules. So an outcome is in the event A or B if the outcome is in A or is in B or is in both A and B. So these are two different types of outcomes. For example, if we let A equal 1, 2, 3, 4, 5 and B is 4, 5, 6, 7, 8, and you want to know the A or B, then you do 1, 2, 3, 4, 5, 6, 7, 8. We don't repeat 4 and 5. We don't list them twice. If you want to know that an outcome of an event is A and B, that's where they intersect or where they cross over, then for this scenario, it's 4 and 5. So A or B is everything. A and B is just where they intersect. So the complement of event A is denoted A prime. A prime consists of all outcomes that are not in A. And make sure you understand that the probability of A and the probability of A prime is 1. Okay, when you add those together, you need to get 1. So if the sample size is 1, 2, 3, 4, 5, 6, and A equals 1, 2, 3, 4, then A prime, what's not part of A, is 5 and 6. And that's 2 out of 6. And the probability of A is 4 out of 6. So when you add those together, you do get 1. There's also something called the conditional probability. The conditional probability of A given B is written as a probability of A conditional to B. It's the probability that event A will occur given that the event B has already occurred. A conditional reduces the sample space. We calculate the probability of A from the reduced sample space B. Okay, suppose we toss a fair six-sided die. The sample space is 1, 2, 3, 4, 5, and 6. Let A equal the faces 2 or 3, and B equals the faces even, which would be 2, 4, and 6. So calculate the conditional probability. We count the number of outcomes, 2 or 3, in the reduced sample space of B equals 2, 4, or 6. Then we divide that by the number of outcomes B rather than S. So the chance of getting 2 or 3 after you've rolled 2, 4, or 6 is 1 out of 3. After we learn more rules, we'll have a formula to calculate this.